So welcome to yet another segment for bonding. This is basically just a continuation of the first lesson that we had for ionic bonding. But in this case now we'll be talking about what? Covalent bonding. So now, like we discussed previously, ionic bonding involves the loss and the what? Gain of electrons, where metals lose electrons and then non-metals they receive electrons. But under molecular bonding, we are having non-metals coming together to form what? Compounds. Where we know to say there will be a sharing of what? Electrons. So meaning this one involves the sharing of electrons. In other terms, we can say it involves non-metals only. So when non-metals come together to form bonds and then become stable, it is basically molecular bonding, aka covalent bonding. So basically, if we look at the periodic table here, each group has got a special name that has been given to it. And then when we talk about group 6 and group 7 elements, they have special names, which is basically chalogens and the halogens, respectively. So group 6 elements are chalogens, and then the group 7 elements are halogens. So now, by nature, these halogens and the halogens, they are diatomic by nature. What does that mean? Diatomic, it means the atom of the same element are coming together to form a what? A compound. So basically, when you are having compound like hydrogen gas, that's a diatomic compound, because two atoms of hydrogen have come together to make a compound. When you talk about chlorine as a gas, we are having two atoms of chlorine coming together to form a what? A compound. When you talk about oxygen gas, nitrogen gas, all these are diatomic compounds, because the same atom is coming together to formulate a what? A compound. So, for example, if we are having chlorine gas, so this chlorine, the neutral atom of chlorine has got an electron configuration of what? 2, 8, and then 7. Why? Because a neutral atom of chlorine has got 17 electrons. It has got 17 electrons. So to write the electron configuration, it will look something like that. But in this case, the compound that we are given is chlorine gas, meaning we are having two atoms of chlorine coming together to formulate a compound. So now, how are they going to share electrons? So meaning, we are going to write our outermost shell like that for the first chlorine, and then our outermost shell like that for the what? The second chlorine. So meaning this is the first chlorine, and then this is the second chlorine, because we are having two atoms of what? Chlorine. So now, this chlorine only needs one electron in order for it to be stable. Also, this one only needs one electron in order for it to be stable. So meaning they are going to share each one electron in order for them to be what? To be stable. So meaning when the first chlorine here, since we are having two chlorines like this, the first chlorine will share an electron, and the second chlorine will also share an electron like that. So when this one shares one electron, it is remaining with 6 electrons. So meaning these 6 electrons are going to be distributed evenly like that. Also, this one, when it shares an electron, it is also going to remain with what? 6 electrons, which are going to be distributed also evenly like that. So meaning these two atoms have become stable. How? They have formed chlorine gas. Because if we count the number of electrons, there is going to be 1, 2, 3, 4, 5, 6, 7, 8. Also, this one is having the same, which is 1, 2, 3, 4, 5, 6, 7, what? 8. So basically, this is how a chlorine gas is what? Formed. Or rather, this is how you show the bonding between two chlorine what? Atoms. What if I given oxygen gas? Oxygen gas. We know to say a neutral atom of oxygen here has got 8 electrons. So meaning the electron configuration for a neutral atom of what? Oxygen is going to be 2 and 6. So now, since we are having 2 here, we are having the first oxygen there and the second oxygen there. They are going to share electrons in order for them to be what? To be stable. So the first oxygen will be written like that, just the outermost shell. And the second oxygen will also be written like that, just the outermost shell. So we're having the first oxygen and the second oxygen. But for this oxygen to be stable, it needs 2 electrons. So meaning it is going to share 2 electrons from its outermost shell. Also the other oxygen will share 2 electrons from its outermost shell. What are we talking about? The first oxygen is going to share 2 electrons like that. Then this oxygen will also share 2 electrons like that. So when they share 2 each, we know to say the first oxygen from the outermost shell there, since it has 6, but it has shared 2, it is remaining with how many? 4. So meaning the 4 electrons are going to be distributed evenly like that. Also this oxygen, it has shared 2. So meaning in its outermost shell, it is only remaining with 4 electrons. So it is going to have 1, 2, 3, and 4. If we count the electrons here, it is very stable. So this is 1, 2, 3, 4, 5, 6, 7, 8. Also this one, it will be the same. 1, 2, 3, 4, 5, 6, 7, 8. Meaning we have created a what? An oxygen gas. Like that. What if we are given something different? Where now we are given to say, what is going to happen when carbon and oxygen react? We know to say this is carbon, it's an element which is a non-metal in group 4, and then oxygen is a non-metal also in group 2, in group 6, meaning the valence is 2. So when we cross multiply, we get C2O4. When we cancel like that, we get a compound we are calling carbon dioxide. So here we are having carbon and oxygen coming together to form what? Carbon dioxide. But how do we show the bonding in carbon dioxide? So we know to say a neutral atom of carbon has got 6 electrons. This is carbon. A neutral atom of carbon has got 6 electrons. So meaning the electron configuration there, it is going to be 2, 4. So, yes, 4. Then if we talk about oxygen, a neutral atom of oxygen, this one here, has got 80 electrons. So meaning its electron configuration there, it is going to be 2, 6. But now, following the formula that we are having here, we are told to say we are having 1 atom of carbon and 2 atoms of what? Oxygen. So if we look at this one here, for this to be stable, how many electrons is each oxygen going to share in order for it to be stable with the what? The carbon there. Are we seeing that one? So meaning we are going to put our carbon on the middle like that, just the outermost shell, and the first oxygen it will be there, just the outermost shell. Also the second oxygen will be there, just the outermost shell. So this is oxygen, and this is our carbon. But now this one here, the carbon has got 4 electrons in the outermost shell and the outermost shell. How many electrons is it going to share to each oxygen in order for it to be what? Stable. So since it has 4, it will share 2 electrons this side and also 2 electrons this side. Why? Because for this oxygen to be stable, it needs 2 electrons. And then for this carbon to be stable, it needs 4 electrons. So meaning it is going to receive 2 electrons shared by the first oxygen and 2 electrons shared by the second oxygen in order for it to receive 4 electrons plus the 4 it has, it is going to contain 8, meaning it has become what? Stable. So here, our carbon here is going to donate how many? 2. 1, 2 to the first oxygen. To the second oxygen, it will do the same, 1 and 2. So now, this oxygen now will also contribute what? 2 electrons. So it will contribute 2 electrons like that, also 2 electrons like that. So even this side, it will contribute 2 electrons like that. So when this carbon shares 4 electrons, meaning here it has remained with nothing, because 2 it has shared there, also 2 it has shared that side. But now when oxygen shares 2 electrons, it is remaining with how many electrons? 4 electrons. So it is going to remain with the 1, 2, 3, 4. Also this one here, it is going to remain with 1, 2, 3, 4. So meaning we formulated our carbon dioxide. So basically this is how you show the bonding in molecules. Basically these are nonmetals coming together to form compounds. And then as usual, they can ask you about the characteristics or the properties for these molecular compounds. One we know to say they contain what? Nonmetals, or they contain molecules. Basically the characteristics for this one, it is just the opposite of the what? The characteristics for ionic bonding, meaning this one is going to have a what? A weak force of attraction between the what? The atoms, meaning it is going to have a low boiling and a low melting point. Also another property that we know there to say these molecular compounds, or rather the covalent compounds, they are going to be insoluble in water, but they are going to be soluble in the what? Organic solvents such as paraffin, petrol, and the like. And then we know to say these ones, they are going now to be the bad conductors of what? Electricity. So basically these and more are some of the properties or the characteristics of these molecular compounds. So make sure to like, share, comment, and also subscribe. Thank you very much for watching. See you next time.